Hi everybody, this video is a recap of today's quiz on systems of equations of three variables, and it started off today with three equations, x, y, and z, and all three equations had all three variables, and the first thing I noticed is that none of the equations is solved for x, y, or z. So first off, I'm going to number my equations, 1, 2, and 3, and I'm going to take this third equation here, and I chose to solve it for y. Now I know some of you solved it for z and solved it for x, and that's a successful strategy too. You really could go either way here. I just chose to solve it for y. So now I'm going to take my transformed equation 3 and plug it into the other two equations. So if I take equation 3 and substitute it into equation 1, I have some work to do here, a distributive property with a negative in it, so you do need to be careful there. And I end up with negative 6x plus 8z equals 46. But something I want to point out here is that you can take that equation and divide it by 2. And if you divide it by 2, the numbers just become a little bit smaller and a little bit more manageable. You don't have to do that, but sometimes it's helpful if you see a GCF to divide both sides by that GCF. Next, I'm going to take equation 3, put it into equation 1. Again, I have to distribute a negative 6, so that's a potential landmine. I have all the work here, and I do end up with negative 4x plus 5z equals 30, and that is not my new equation 2. So now I have a system with two variables, x and z, and I want to solve that system. There's a couple ways I can go here. What I see here is I have negative 3x in the top equation, negative 4x in the bottom equation. I could make them both into 12 by some strategic multiplying. And you'll notice I get a negative 12x in equation 1, negative 12x in equation 2. Since they have the same coefficient, that means I can subtract. And subtraction is sometimes where you have some issues here. But if you subtract down, it comes out quite nicely, z equals 2. Once I know z equals 2, I can plug that into any equation that I see. I'll plug it into equation 1. I do some simplifying, and I'm all set, and I can figure out that x equals negative 5. And once I have both z and x, I'm home free. Equation 3 is what I chose to use here. I plug them in, I get y equals 1. So my solution is negative 5, 1, 2.